So, today's whole cool thing is to solve exponential equations, which we haven't done many of. And so the first one I'm going to write, and you might want to take notes, I don't know. 5 to 3x. All right, I wonder if the people at home can see that one. Yep, they can. Good. So the whole thing today, because we don't need logs, which will be taught tomorrow, partway through tomorrow, is we need to have the same bases. We need to have the same bases. Somehow, I need to get the number 1 to have a base of 5. 5, is there any way I can make a base of 5 and do something with an exponent to make it worth 1? Anything to the 0 power equals 1. So if I change this 1 into a 5 to the 0 power, and why you know how to do this is I'm telling you today we're going to need to have the same bases on each side of the equation. So you look at it and go, how in the world can I get that to be a 5? Anything to the 0 power is 1. So now we have a same base. That's cool. Once the bases are the same, all we need to do is get the exponents the same, and that means we can ignore the bases and do a little Algebra 1 skills. Hi. Please be for me, please be for me. This has to be good because it's on green paper. Okay? Okay. I just held the green paper, and I just looked at the name and the first word. So green paper means it should be good. You have green paper. Was your green paper good? Okay. Faith's green paper was good, so I hope your green paper is good. I'm only reading the first word. First word is good. Is it good? Okay, it's good. First word's congratulations, so I assume it's good. I mean, what the first word says. Congratulations on something. All right. Hey, let me go back here, please. Double check. 3 times -8/3 is -8. -8 plus 8 is 0. 5 to the 0 is 1. It double checks. All right. Next one we're going to try.
So the 5 doesn't matter at all.
So why don't we find a base?
We both have a 5 as a base. When I get 8/3, 3 times 8/3, that is -8 plus 8 is 0. 5 to the 0 power, yes, it equals 1.
So you can paste that in your calculator to check, right?
You could, absolutely you could. All right, today I have to tell you this. Today is based on getting the same base. Okay, today is premised on getting the same base. All right, so huge hint on the 243, what its base is going to be. Get your fingers out. 3 times 3 is?
9.
Times 3.
27.
Times 3.
81.
Hint, look at the board. Times 3. 243. 3 to the 5th power is 243. Hint, if you see a 3 here, it's probably going to be a 3. So this is the board we're looking at. I said the wrong board. All right. So this is 3 to the 5th power. Again, today that's what's going to happen. You're going to be able to get the same bases. And now, once we have the same bases, it's just we need the exponents to be the same. And so now we can forget about the bases to solve the problem. X equals 0. We sure could use our calculator to double check. 2 times 0 is of course 0 plus 5 is 5. 3 to the 5th is 243. A woo and a who. Woohoo, woohoo. Do I have enough time? Oh, do I ever. All right. Okay. Okay, before we continue on this problem, I just want to remind you of something. Don't write this down. X to the third times x to the second is x to the fifth. You just write the x down once, correct? So if I have 7 to the third times 7 to the second, it's 7 to the fifth. You just write the 7 down one time. Cool? So now on this problem, when I've got 7 to the 3m, 7 to the negative m, I can add the exponents, add them up, and I just write the 7 down once, just like the things I erased. And now it becomes algebra 1. If I know how to write m's, I'll edit that out. Negative 5 halves. 3 times negative 5 halves, that's 7.5, minus 2.5, it is 5. I'm sure you've watched my videos because some of them get 98 views.
Yeah.
I don't edit out
Can
any.
we go up in the video?
I don't edit.
featured?
I don't edit out anything. I don't edit out anything.
I'm gonna edit this out, just to test us.
I'll edit it out. I have. No, I'm gonna stop.
Okay, good.